So each piece, each term is a monomial only if you only have exponents that are positive, and those exponents can't be fractions or decimals either. They've got to be integer numbers. So I think all of these guys up here are polynomials. Do you guys see any issues with that? So let me show you some examples of things which are not polynomials. Things like 3 to the x plus x squared. That's not a polynomial. Why? Is this part good? Yeah, but Logan?
Because the x part is having.
The x part could be kind of anything, right? This was an exponential function that we just barely started to look at last time. So it's not a polynomial function. This could be like fractions and stuff since it's x, so that's definitely not a polynomial. So if I had, it has to be an integer and it has to be positive. So if you had something like this, we've even seen some things like this, right? That'd be like 1 divided by x squared if you moved it to the bottom, right? That's what negative exponents mean. That's not a polynomial, it's some kind of other function which we'd have to study separately, okay? If you had something like 1.5 power, that's also not a polynomial. That would have its own issues. That's actually a kind of square root-ish type of function. So we can talk about that in Algebra 2. Okay? So I'm just talking polynomials, things with nice integer powers. Those are the things I'm talking about. Okay? So you're going to be asked a variety of things. For instance, some of these guys are in what's called standard form, and some of them are not. So what's it mean to be in standard form? For a polynomial to be in standard form, its highest power thing has to come first. The term with the highest power needs to go first. So what do you guys think? Is that first one in standard form?
Yes. Well,
Is the highest power term first?
No.
No, if I put it in standard form, which thing should come first? The negative 18x to the fifth. And just remember, what's the thing attached to the numbers called? I bet you guys have heard of that term before, maybe not. I'm not sure. So attached to each variable part, there's a thing called the coefficient. So the things that are attached, the coefficients, always stay attached, right? So the 18, the negative 18, is attached and has to stay attached. So then what is supposed to come next if we're going to put it in standard form? Which one?
Plus 12x.
Yeah, the 12x squared. Thanks, Richard. Sweet. So that's the next highest power, and then what's the final one, of course? Plus 4x. Does that make sense? Notice the coefficients stayed attached the whole time, and it's in what's called descending power order. That's standard form. Okay? So let's make sure that these are all in standard form. How about this guy? Is this guy good to go?
yes.
Yes. How about this guy?
No.
No. What does it need to do?
Cube.
Yes. Yara says this guy comes first. Very nice. And then
The minus y squared.
the minus y squared, and then
20y.
20y, and finally just the 2. Okay, that's now in descending standard form. So that's what they're asking if they ask for standard form or descending order or something like that. Okay? How about this guy? Is he set? Good go?
No.
Almost. Don't we really just need to switch these two?
Yeah.
And then I think we're good. So I'll write it down again. Making sure that I keep my coefficients attached. The things in front always stay attached. Sometimes students don't do that. And this guy, of course, is not good to go either. What's supposed to come first, Taylor, on this one? Yeah, okay. Plus 120x, right? Plus 12. Okay, so now they're all in standard descending order. So that's good to go. So they could also ask you first to dissect them, to pick out some specific things. And they could ask for a variety of stuff. For instance, they might ask you for the degree. So let's do the degree on each one. So the degree is simply the highest power. So if it's in descending order, you've made your life real easy. So what's the degree on the first one, Caden? That's a coefficient. Degree is the highest power.
Oh, we just put x in the
Yeah, but just the power, just 5. Does that make sense?
Yeah.
That's a degree 5 polynomial. That's how you say that. This guy's a degree 4 polynomial, this guy's a degree. I should look at the descending form, right? Degree 3, this guy's degree 8, this guy's degree 2. Okay? Look how easy that is once you're in descending order. So Caden was trying to give us another thing which they might ask for, ironically, and that is called the leading coefficient. So there's lots of coefficients. Those are just all the attached numbers. What do you think leading coefficient means? The first one. Well, it could mean the lowest too. That'd be like the trailing coefficient, right? So they could ask you for that too, but that's not as important. You'll find out when you look at polynomials and study them. So the leading coefficient actually makes a difference. So what's the leading coefficient for this guy? Negative 18. If it's in descending order, that should be easy to pick out. So the leading coefficient, I'm going to abbreviate. You guys can do that if you like. 6, and here, -8. One thing when you're doing your assignment, anyone watching the video and in my class, make sure that you write down the problems. This is an assignment where you really need to write down the problems because you need to start looking at these and being able to just look at this and say, hey, leading coefficient is -3 on this one. The degree is 8 on this one. Linking that visually is key, so don't just not write down the problems on these. This is a big time important lesson where you need that. So leading coefficient here is -3, and here, of course, is -4. Okay? They might also ask you for the constant term. So that's the thing without a variable. So the constant term on this guy is, I'm not going to write it down this time, so we're getting jammed up, okay? What's the constant term for this guy? Is there a term without a variable? Oh, there's X on that one. There isn't one, which means the constant is, which means it's 0. Good. Constant on this guy is 0. How about this guy? 0. How about this guy? 2. Does that make sense? How about this guy? Constant is 10, and this guy 12. Okay. So they might ask you for that. Let's see. The only other thing I can possibly imagine them asking us for is a name. So let me see. I have a green. Okay, so naming conventions. How do you name these? So you use the degree, use the information we've got on the board. So this guy, you can name each one 2 ways, and whether the book asks or not, I'd like 2 names for each one, please. So, 5th degree. There's a little table in your book, too, for this, so you can look it up on the internet. 5th degree is called quintic. Okay. How many terms does that have? 3. So polynomial, poly is Greek for many. In other words, many monomials, many terms. So how many do we have? 3, so this one's a trinomial. So this is a quintic trinomial, that's its name. All right? This guy's degree 4. Degree 4 is called quartic. And 2 terms, it's a quartic binomial.
I was thinking dinomial.
That's good. That's a good guess. Great. I wouldn't really be wrong. I'd probably give you that on the test. This guy, well, degree 3, it's called cubic. Which is kind of weird because, you know, you think of a cube, you think maybe 4 sides, but there's not really 4 sides on a cube. A cube has how many sides? 2, 6, so whatever. Cubic is the word. And how many terms? 1, 2, 3, 4 terms. So you call that a tetranomial. I don't think that one's in your book. This guy, 8th degree. So you might be thinking like oct or something like that. 8th degree, I don't think we need to know. That's probably enough. Up to 5 is sufficient for us this year. So I don't even know the name of an 8th degree. I might be making stuff up. So let's say 8th degree. 1, 2, 3, 4. We did that one.
Tetranomial.
That's the tetranomial. Yeah. There we go. I have to look that one up. 8th degree. I'm sure there's a name. And this guy is going to be our most common friend for chapters 7 and 8. trinomial, right? And degree 2 is quadratic. You may have heard of like the quadratic formula. If not, you're going too soon. Okay? So there we go. There's pretty much everything you need. There's a couple problems, couple applications. I'm going to post a couple examples from the text. They're really easy ones. They're just like saying, here's a polynomial, here's a value for x, and they're having you plug it in and interpret. So those problems, I want you to focus on the interpretation. Other than that, it's just kind of plugging in. You can use your calculator to help you do those, so it shouldn't be a big deal either. All right? Maybe one last, little more challenging one. What if the degree is 1? Good question. So you're talking about something like this, right? Then it'd have to be like x plus 8 or something. So the constant's 8, the degree is 1. Remember, these all could have what in front of them? Have we seen this?
Yeah. A lot.
What is that? Slope-intercept form of a line. So it's a line. Does that make sense? Good question, Logan. This is a line, and a line, if you have two pieces, is a binomial, technically. So lines are one specific kind of polynomial. Good question.
So you want to count the y equals as...
Yeah, right. You're not going to have that. We're just going to focus on the other parts. Good question, too. All right, so one last challenging one. Here's maybe a little higher level one. So here's one. Let's see if you guys can tell me. Same info on this one. I'll give you a second. A little more challenging. I'm sure there's nothing in your assignment like this, but I think we can handle it.
Oh, that's pi x.
Take a second, think about it, talk to your partner. Okay, I think we've had enough time to think. So, the sneaky part about this one, like I said, is a couple of you mentioned this has a negative exponent, so is it even a polynomial? But it is, because this is just one number. That's not x, that's times, like Sheridan said. So this is just a number. So if we order it, what thing comes first? Pi x to the fourth, that's first. What's next? X squared, good. And then next? I think minus 12, and then this thing. So what is that thing? Well, if you change it into regular notation, from scientific notation, I think it'll be easier to think about. So let's do that. So it's minus what?
Minus 0.000708.
Perfect. Thanks, Colton. Negative 4 exponent means 3 zeros, right? So really, that's part of the constant. So the degree on this guy is 4. There. Leading coefficient, pi. So leading coefficients can be weird numbers like pi or the square root of 2 or a non-terminating decimal. It can be anything. The constant is, careful, negative 12.000703. This whole thing together is negative 12.000703, right? And the name. You guys help me with the name? Kayla, you guess? Quadratic is degree 2. Quartic.
Oh, Kayla, how did...
Quartic tetranomial.
I got the tetranomial.
Cool. Cool. And if you can at least get one, that's pretty good. Definitely for today, right? Okay, so there you guys go.